Hi and welcome to another video for additional maths year 9. So we're going to deal with chapter 8, which is about series. So the first a few subtopics about this one is about binomial expansion, but the basic comes from what we call Pascal's triangle. So Pascal's triangles is related to the expansion of, if say you have a plus b to the power of n, where n will be 1, 2, 3, 4, and 5. So the thing that you will do is you will write down coefficients of expansions of this type of algebraic expression. Okay, and then one of the things that you will notice also that you will use the patterns of the powers of variables of each successive term when you have to write down the expansions of a plus b to the power of n, and a plus b could be different terms altogether, but let's have a look at the first one. Okay, so here first of all, binomial expansions are algebraic expressions with two terms. For example, here if you have x plus 5, so this is considered two terms, and 2x minus 3y is also considered two terms. Okay, now from here you should already know that a plus b squared is this one. So this is the expansion when you do normal basic ones. So you have a squared plus 2ab plus b squared. Now take note of this one. So what happens next is that we can use a plus b squared to expand a plus b cubed. So a plus b cubed is this one, can be broken down into these two multiplication, and there you have a plus b squared there, which is a squared plus 2ab plus b squared. So if you continuously doing the expansion, you will have another result after simplification, which is this one, which is a cubed plus 3a squared b plus 3ab squared plus b cubed. And similarly, if you happen to multiply a plus b to the power 4, you do the expansion, you will get this result. So if you write down the expansion in order, so have a look at the number pattern. So for example here, if you have a look at the expansion of a plus b to the power 4, we notice that the powers of a and b form a pattern. So for example here, if you have a look at the power of a to the power 4, and then the next term is a to the power of 3, a square, a to the power of 1, and then a to the power of 0 here. So a to the power of 0 is a 1. So there's no a anymore over here. And then when you have a look at the power of b, so for the first term there's no b yet. But as you go into the next term over here, the b to the power of 1, there's b to the power of 2, b cubed, and b to the power of 4. So here, this is a pattern that you have noticed. So here, the power of a decreases by 1, right? And the power of b increases by 1 in each successive term. So you look in order. And then, all of the terms have a total index of 4. So what does that mean is that when you have a look at the power of a to the power of 4, over here, a to the power of cube and b to the power of 1. So the index has a total of 4 for the second term. So let's have a look at the next term. Also the same thing over here, a squared, b squared. So the index added together, you will have a 4. And over here, this is also 4, and the last one is b to the power of 4. So this pattern can be also be seen in other expansions. So let's have a look over the next page. So here, the coefficient, okay, apart from the index, which is the previous one, you have to look at also the pattern of the coefficient. So the coefficient also form a pattern known as the Pascal's triangle. So this Pascal's triangle is when you have a row that always start and finish with a 1, and then each number is the sum of the two numbers directly above it. So like here, 1, when you go down, it directly goes to 1 over here in this number. But for the 2, how will we form? Number 2 is that we have a 1 from here and a 1 from here. Added together, you get 1. So this is a continuous pattern as you go down the row. So here 1 plus 2 is 3, 2 plus 1 is 3, and this is a continuous 1. In the end of all the rows, they're always 1, but here, in the numbers in between are added together. Okay, so for the last one, for the fifth row over here, first, second, third, fourth, and fifth, for the fifth, fourth here, so this one is obviously 1 plus 4. So 1 plus 4 is a 5. And then over here, 4 plus 6 is a 10. And here, this one is also a 10. And this one is 4 plus 1 is a 5. So here, we can use this row to help us to find the expansion of A plus B to the power of 5. So here, let's say I will write down the A in purple over here, and the B is in red. So here, if we follow the number in the fifth row over here, the first term is going to be A, 1, A to the power of 5. But B does not exist yet. So B here is B to the power of 0 actually. And then as we continue to the next term, the second number in the fifth row is a 5. So it is a 5. And then the power of A will be decreasing based on this fact over here. So the power of A decreases by 1, while the power of B increases by 1. So here, A to be A to the power of 4, and then B will be B to the power of 1. Right, and then the next one. The next term will have a coefficient of 10. And then A to the power of 3, it keeps decreasing. But the power of B will increase into 2. And then the next term will be 10. And A is going to be A to the power of 2. But then B will increase to the power of 3. And then the next term will be a 5. 5, A to the power of 1, which is just A. And then B to the power of 4. So the next term is going to be the last term for this expansion. So the A will be A to the power of 0, but then B will be B to the power of 5, and the coefficient is 1. So here you go, this is the expansion of A plus B to the power of 5. So let's have a look at the example here. Okay, use Pascal's triangle to find expansion of this one. So here, just we have to take note of the power first, which is to the power of 3, the index. So here, based on the power, it will determine which row are we going to use. So if it is power of 3, then you will use the third row of Pascal's triangle to write down the coefficients. So over here, just take note, therefore, it is going to use third row of Pascal's triangle. So the Pascal's triangle's third row consists of number 1, 3, 3, and 1. And take note of the A and B over here. So the A is going to be 2, and then the B is going to be positive 5x. So let's start with the expansion. 2 plus 5x to the power of 3 is going to be, right, so the first term will have a coefficient of 1, and then the A will be A to the power of 3. So the 2, the 2, which is your A, is going to have a power of 3, and the B is not here yet. So let's have a look. Let's move to the next one. Okay, the second term will use a coefficient of 3, and the A, which is 2, will be to the power of 2. It will decrease, but you will have a new one, a new term over here. So here, I just do a bit of correction over here with the power. But then here, there's a 5x will appear as to the power of 1. Right, so let's move on to the next term. The next term will use a coefficient of 3. And A, which is 2, will be to the power of 1. But then the 5x will have a power or index which is 2. It will increase. And last but not least, you have the fourth term, which is with a coefficient of 1. And 2, there's no longer 2 to the power of 0 is a 1. But then the last term will have a 5x, which is b. b to the power of the highest power for this expansion is power of 3. So now you have to multiply this carefully and simplify if necessary. So let's have a look at all the numbers first. When I do this one, I will be quite careful with multiplying the numbers because you see here there's a lot of numbers in one term and a lot of power in one multiplication. So let's do as simple as we can. So let's begin. 2 to the power of 3 is an 8. And then I will not really multiply them straight away. I will break down a 3 and then 2 square is a 4. I put inside a bracket and 5x power 1 will have no change. So here you see it's easier to multiply. And then the next term will be 3 and then 2 to the power of 1 is 2 and 5x squared is 25x squared. Alright? And for the last term, 5x to the power of cube will be 125x cubed. So here you will have to do last multiplication to get the whole expansion, which is 8 plus 3 times 4 times 5 is going to be 60, right? So 60x, and then 3 times 2 times 25 is going to be 150, and there's an x squared plus 125x cubed. So there you have it. This is the expansion of 2 plus 5x to the power of 3. Alright, so let's move on to the next expansion. So the next expansion is the part B, which is 2x minus 3. So your A over here is 2x and B is your negative 3 with a power of 4. So if you're using a power of 4, that means you are going to use the fourth row of the Pascal's triangle as your coefficients. So here the fourth row of Pascal's triangle is, let's refer to the previous one. The fourth row is going to be 1, 4, 6, 4, 1. So 1, 4, 6, 4, and 1. So let's proceed with expansion. So here your expansion is using 2x minus 3 and to the power of 4. So let's proceed with the multiplication. Now here you begin with your a to the power of 4. So a is your 2x and a power of 4. The coefficient is 1, okay, forgot to write that down, okay, just to be careful here. And then the next term will have a coefficient of 4, and your a, which is 2x, will have a power of 3, which is decreasing, and there is a negative 3. Your b will be having a power of 1. Next, the next term will have a coefficient of 6, and the a is 2x to the power of 2, and your b, which is negative 3, will be to the power of 2. And the next term will use the coefficient of 4, and your a will be 2x to the power of 1, and your b, which is a negative 3, will be cubed. Right? And last but not least, your coefficient is 1 plus 1, but there is no longer a because 2x power 1 to power 0, and then your b is negative 3 to the power of 4. Right, so there you have it. Let's have a look first. Right, So that's for the expansion. All right, now let's simplify this one. So over here, it's a direct 2x to the power 4. So 2x to the power 4 is a 16x to the power 4. Plus, let's have a look here. 4 and 2x cubed is an 8x cubed. And negative 3 to the power of 1, it's still a negative 3. So here, have a look carefully with the terms. And then the next term is going to be 6. 2x to the power of 2 is going to be 4x squared. And then negative 3 squared is 9. And the next term is 4 bracket 2x. And negative 3 to the power of 3 is a negative 27. And for the last term, 1 to the power of negative 3, 1 times negative 3 to the power of 4 is a positive 81. Right, so you're almost there with the final expansion simplification here. So let's simplify this one. So 16x to the power of 4. And for this one, let's multiply 4 with 8 and also negative 3. So this is the coefficient of x cubed, which is 96x cubed. And as for the next term, 6 times 4 times 9. So this one is a 216 and x squared. And the next one is 4 times 2 times negative 27. Negative 27. So this one is a negative 216 also. And x, right? X to the power of 1. And last but not least, plus 81. So this is the expansion for part B, which is 2x minus 3, everything to the power of 4. Alright, so let's move on to the next example. The next example is regarding expansion of 2 minus x to the power of 5. And for part B, find the coefficient of x cubed in the expansion of 1 plus 3x bracket 2 minus x to the power of 5. So over here, to answer part B, you have to know the expansion of 2 minus x to the power of 5. So here, there's a correlation between these two examples. So the first part, A, let's expand 2 minus x to the power of 5. So over here, this is a power of 5. So if the power is a 5, then therefore you are going to use the fifth row of Pascal. The fifth row of Pascal's triangle, let's refer it back. Refer back to here, it is 1, 5, 10, 10, 5, 1. So here, this is a 1, 5, 10, 10, 5, 1. 5 and 1. So let's begin. So 2 minus x. So 2 minus x to the power of 5 is going to be, okay, so here it's going to be quite a long expansion. So I'll begin with a new row. So let's start. The coefficient of the first term is a 1 and a is 2. So 2 to the power of 5. Right, that's the first term. The second term, the coefficient is a 5. The a will have a decreased power. So decreasing the power of 5 will be a 4. And you will have a b to the power of 1. So that's the second term. The next term will have a coefficient of a 10. And the a will have a decreased power. So it's a 3. And negative x will have an increased power. So from 1 it will become a 2. And then for the next term, it's going to be plus 10. And then there's an a. A will have a power of 2. And the negative x will have an increased power. So it will become a 3. And the next term is, okay, let's continue here. It is a 5. as the coefficient, right, based on the next term, and the a will have a power of 1, and then the b, the negative x, will have a power of 4. And last but not least, the last term will have a coefficient of 1, and then there's no longer a, but we will have a b. The b, which is the negative x, will have a power of 5. So there we have it. Let's check them term by term. So there's no problem here. The Pascal's coefficient is okay. The power of a will decrease and the power of b will increase. All right. So let's move on to the next one. The next one over here, let's simplify what we can have first. So here 2 to the power of 5 will be a 32. And there's a 5, the second term, 5. 2 to the power of 4 is a 16. And there's still negative on negative x. And then 10. 2 to the power of 3 is an 8. And negative x squared is going to be a positive x squared plus 10 to the power of 2 is a 4, and negative x cubed, it's still going to be the negative x cubed, and 5 and 2 and x to the negative x bracket to the power of 4 is going to be a positive x power 4, and positive 1 times negative x to the power of 5, it's still going to be a negative x to the power of 5. So here you can simplify them. So 32 and 5 times 6 times negative x is going to be, let's say the negative x have the coefficient of negative 1, so it's going to be negative 80. So minus 80x. 10 times 8, the next term will be 80x squared. And here 10 times 4 is 40 times negative x cubed will be minus 40x cubed. And 5 times 2 is going to be a 10 plus 10x to the power of 4. And lastly x to the power of 5. So this is the complete expansion of 2 minus x to the power of 5. So the next one is find the coefficient of x cubed in the expansion of 1 plus 3x. Okay, so let's write down that one first. The 1 plus 3x. 1 plus 3x bracket times 2 minus x to the power of 5. So here, this one is actually from your previous part A. So this thing, before you can expand this one, you have to write down the 1 plus 3x is still there, but this one, this 2 minus x to the power of 5 will be replaced by this whole thing, which is 32 minus 80x plus 80x squared plus 40x cubed and minus 40x cubed plus 10x power 4 and x to the power 5. Right? So here you will rewrite all of this again to be put into this one. So this is the expansion of the previous part. So here, this is the real question in which you have to find the coefficient of x to the power of 3. So let's have a look at the term that will have x to the power of cube. So over here, for this type of question, you don't have to expand everything. You just need to expand what you need to have, which is x to the power of cube. So say, if I were to multiply 1 with the next bracket by using expansion over here, so the 1 you will have to multiply with only the term with x cubed, which is negative 40x cubed. And as for the 3x, that's the second term in the first bracket, you will have to multiply it with something that will give you x cubed after multiplication. So here the positive 3x will be multiplied with 80x squared. So let's have a look at expansion. So here 1 will be multiplied with negative 40 x cubed. And the plus 3x will be multiplied with 80 x squared. So here you just have to simplify this. So 1 times negative 40x cubed is negative 40x cubed. And 3x times 80x squared will be 240 x cubed. So this is the term. Okay, negative 40 plus 240 is 200 x cubed. So this is the term that contains x cubed. But the question is asking you about the coefficient of x cubed. So here you can see, therefore, coefficient of x cubed is going to be 200 over here. So there you have it for the last example for this subtopic. So here it is. That's all for this video. I hope that it will help you with your note taking. So with that, thank you very much and see you in the next video. Thank you.